Welcome to the deep dive. We're here to unpack complex ideas, pull out those essential nuggets of knowledge. Imagine, just for a second, being able to see almost anything, anywhere on Earth, right as it's happening. Like a natural disaster unfolding, or maybe hidden events way out in remote corners of the world. It almost sounds like science fiction, doesn't it? But, well, it's actually our reality now.
It really is. And today, yeah, we're taking that deep dive into how satellites, especially when you combine them with artificial intelligence, are just completely changing our ability to see, to understand, and crucially, to respond to global events.
Right. And this affects so much, doesn't it? Everything from, say, disaster relief getting there faster to journalism, human rights.
Even predicting what might happen next on our planet. It touches almost everything.
So for our insights today, we've looked at a whole range of sources. We've got stuff from leading tech companies, think EOS data analytics.
Plan out. Big names in the field.
Exactly. Plus academic research, places like the Chris Michelson Institute, GFZ. And then there's expert analysis on things like open source intelligence, OSINT, and the really important ethical side of things from Viterbi and the Engine Room.
Yeah, a really solid mix. And our mission, really, is to give you that shortcut, a way to get properly informed on this really transformative tech.
We want to cut through all the noise, right?
Exactly. Find the most important bits, maybe some surprising facts, and definitely highlight some of the maybe unexpected implications of having these eyes in the sky.
We're aiming for those aha moments, leaving you with a much clearer picture of how this whole landscape is evolving.
Okay, let's dive in.
All right, so when most people hear satellites, I think the first thing that comes to mind is probably GPS, right? Guides us everywhere.
That's the everyday connection, yeah.
But what these things orbiting above us actually do, it goes way, way beyond just telling us where to turn left.
Oh, absolutely. Satellites give us this indispensable imagery. It's timely, it's high resolution, and it basically gets around the huge limitations of trying to assess things from the ground, which can be dangerous or slow or both.
And the scale is just huge.
It's massive. As of, May 2023, there were over 7,500 operational satellites up there. And get this, 91% of the U.S.-owned ones belong to commercial companies.
Wow, really? 91%?
Yeah, it's a commercial space now, largely. And these sensors, they're collecting data on everything, weather, obviously atmospheric stuff, but also incredibly detailed optical images, radar, tracking locations.
It feels like this constant global eye, but it's not just about seeing things in real time, is it? There's this element of almost time travel.
That's a great way to put it, yeah. Satellite imagery lets us tap into historical archives. You've got companies like Digital Globe, Airbus. Their archives go back to the late 1990s.
So researchers can literally go back decades.
Exactly. They can collect evidence from past events, maybe track environmental changes over time, document what happened in conflict zones years ago. It's incredibly powerful.
And you mentioned different kinds of sensors. Optical radar, it's not just like a regular camera.
Not at all. Optical is, visible light, like our eyes see.
Right.
But then you have SAR synthetic aperture radar. That's the really interesting one in many ways.
Why's that?
Because SAR sends out its own radio waves and listens for the echo. This means it can see right through clouds, total darkness, even dense jungle canopy.
Seriously? Through clouds and darkness?
Yep. And sometimes it can even give information about what's just below the surface, underground. It adds this whole other dimension to what we can see from space. It's not just looking, it's actively probing.
Okay, so let's talk about where this tech makes a really tangible difference. Natural disaster response, humanitarian aid. The impact there seems enormous.
It's genuinely transformative. In a disaster scenario, earthquakes, hurricane, flood satellites are absolutely critical. They let responders quickly see the extent of the damage, figure out where resources need to go most urgently, and get relief efforts moving faster.
Can you give us some specific examples? Where has this really shown?
Sure. Hurricane Harvey back in 2017, satellite imagery was just instrumental. Assessing critical infrastructure damage, pinpointing the hardest hit areas needing immediate help. It literally guided the first responders.
Wow.
Or the 2015 Nepal earthquake, really remote, difficult terrain. Satellites quickly helped evaluate building damage, infrastructure, and even spot potential landslide risks that wouldn't have been visible otherwise.
And you mentioned AI earlier. Does that play a role here too?
Increasingly, yes. Look at the 2018 California wildfires. AI and machine learning were used to analyze satellite images in real time to predict how the fire might spread. That directly helped firefighting strategies and evacuation planning.
So it's not just seeing the damage after it happens, but also trying to get ahead of it.
Exactly that. Satellites can help predict things like lava flow paths or how a flood might evolve. That lets authorities direct people to safety before disaster strikes. And then there's the longer-term stuff, like assessing crop losses.
That must be huge for food security.
Massive. We're talking, what, over $21 billion in U.S. crop losses just from 2022 weather disasters. Satellites help quantify that. And SAR technology, the radar, is great for monitoring agriculture, how crops are progressing, water usage, providing insights for future planning.
How are humanitarian groups using this on the ground day to day?
Well, humanitarian mapping is a huge application. Doctors Without Borders, for example, they use geospatial tech to map over 90,000 unmapped buildings in Guinea during the Ebola crisis, literally putting places on the map so they could respond effectively.
Very incredible.
And beyond that, you have entities like Frontex, the European Border Agency, using Copernicus satellite data for coastal and maritime surveillance, looking for illegal flows of people, weapons, drugs.
And there's specific projects for things like migrant vessels.
Yeah, projects like Space Shepherd specifically monitor the Mediterranean Sea, providing that vital situational awareness. And of course, the UN has its own dedicated unit, UNASA.
Yeah, UNOSAT. What's their role exactly?
They provide rapid mapping services, 24/7, for natural disasters and human conflicts anywhere in the world. They feed crucial data directly to UN agencies and other humanitarian orgs. It's a critical piece of the global response puzzle.
Moving beyond humanitarian aid, this satellite imagery analysis is also, well, revolutionizing journalism and how we monitor global events, isn't it? It must give news outlets a massive edge.
Oh, absolutely. It's a competitive advantage. It lets them monitor remote or, frankly, dangerous areas safely and relatively cheaply. They get a unique viewpoint nobody else has.
And visually, it must be incredibly compelling.
Definitely. Satellites capture these powerful visuals, disasters unfolding, conflict zones, environmental shifts. Those before and after comparisons are particularly striking. It's like giving people a first-hand view, even from orbit.
And it's not just a static picture. They can track events over time.
Yeah, that's key. Journalists can access the historical archives we talked about, or they can actually task a satellite.
Task a satellite. What does that mean?
It's like commissioning a photo from space. You tell the satellite operator, I need an image of this specific spot at this specific time. Depending on the budget, you could get updates daily, even hourly sometimes.
Wow.
So they can stay really current. And it's not just the basic photos. You can get more advanced data products, like the Enhanced Vegetation Index, EVI.
EVI.
Yeah, it measures plant health and density using specific light wavelengths. It gives you much deeper data-driven insights than just looking at a green patch on an optical image. You can see drought stress, crop yields, that kind of thing.
Let's talk about 2020. That was such a unique, historic year. Satellites must have captured some incredible moments. What did those eyes in the sky show us?
2020 was, yeah, extraordinary to see from space. You had Maxar imagery showing Wuhan almost deserted during the early COVID lockdowns in January.
Yeah.
Then just weeks later in February, boom, images of rapid hospital construction.
That's amazing speed.
It was. And remember the Australian bushfires? Maxar used its shortwave infrared sensor, SWARE, which can see through smoke, to show the active fire fronts. Unbelievable detail.
And the environmental impact of lockdowns, too.
Oh, yeah, that was striking. Significant drops in air pollution over major cities worldwide. You could literally see cleaner air over Spain, the Northeast, U.S., India. A direct visual of reduced human activity.
What about the human side of things? Things people were doing or not doing?
That was visible, too. Images of empty religious sites, the Grand Mosque in Mecca, St. Peter's Square during suspended pilgrimages were really powerful symbols of the global pause. But then moments of progress, too, like the historic SpaceX Falcon 9 launch, the first commercial crewed flight. Satellites caught that.
So it captured the whole spectrum. Geopolitics, social events.
Absolutely. Geopolitical tensions, like the Chinese buildup on the border with India Planet satellites captured that. Hawkeye 360 used radio frequency analytics alongside imagery. Social unrest, too. Remember the Black Lives Matter message painted on the street leading to the White House? Clearly visible from space. Environmental disasters like the oil spills in Russia's Arctic and off Mauritius. Massive wildfires across the U.S. West Coast Maxar showed the scale.
Humanitarian crises?
Sadly, yes. The destruction of the Moria refugee camp in Greece. And evidence related to human rights concerns like the Australian Strategic Policy Institute using satellite imagery to identify destroyed or damaged mosques in China's Xinjiang province.
It really documented everything: sensitive sites, natural phenomena.
Yeah, the damage to the Arecibo radio telescope, reports of Iran rebuilding a nuclear facility, and natural events like record-breaking hurricane seasons or tracking that massive iceberg A68A breaking off Antarctica.
Looking back at 2020 through that lens, it really feels like satellites became this undeniable, omnipresent witness, didn't that? Changing how we saw global events in real time.
Completely. It wasn't just reporting on events, it was showing them in a way that was hard to dispute.
Now, we touched on human rights concerns there. It's clear this imagery is powerful for news, but it plays a specific, maybe less visible role in human rights monitoring, too.
Increasingly vital, yes. It's used more and more to monitor and investigate human rights abuses, violations of international humanitarian law. Experts usually break this down into three main ways it's used.
Okay, what's the first?
The most common is probably before and after comparisons. Very powerful for showing destruction or changes.
Like documenting destroyed villages.
Exactly. Human Rights Watch used it to investigate 430 destroyed buildings in Rohingya villages in Myanmar. Concrete visual evidence. Amnesty International verified over 3,700 structures destroyed by Boko Haram in Nigeria using satellite images.
Wow.
They also used it to track oil spill damage in the Niger Delta over 5 years. And Physicians for Human Rights even managed to locate mass graves in Afghanistan using historical imagery analysis.
That's incredibly grim, but vital work. What's the second category?
That's tracking trends. So looking at widespread phenomena over time or across large areas.
Give me an example.
Amnesty's Decode Darfur project was a big one. They used crowdsourcing volunteers, analyzing thousands of images, covering a massive 326,000 square kilometers to track patterns of destruction over time.
And UNOSIT does this too.
Yes, UNOSIT has been continuously monitoring the Syrian conflict since 2011, building this long-term, undeniable record of changes on the ground.
Okay, so before and after, tracking trends.
Oh.
What's the third way?
That's ongoing monitoring, which often involves tasking satellites, like we discussed for journalism.
So actively watching specific spots.
Right. Organizations like 38 North regularly task satellites to image North Korean nuclear sites, keeping a close eye on developments. And this kind of active monitoring has been really crucial in investigations of potential war crimes in places like Gaza, Georgia, Sri Lanka.
Can just the possibility of being watched make a difference?
Sometimes, yes. The Satellite Sentinel project, which focused on Sudan and South Sudan, explicitly used the threat of ongoing satellite monitoring as a deterrent, trying to prevent conflict escalation. The idea that the world is watching from above can, sometimes, be a powerful preventative tool.
Okay, so we have all this incredibly powerful satellite data, but you mentioned AI earlier and machine learning. That really seems to turbocharge everything, right? Creating these complex data ecosystems.
That's absolutely spot on. Integrating AI and machine learning, it's completely changed the game for processing and analyzing satellite data.
How so?
Well, think about the sheer volume of data. It's immense. These algorithms can chew through vast amounts of it. Satellite images, sure, but also data from IoT sensors, social media feeds, you name it.
And they find things humans would miss.
Or things that would just take humans an impossibly long time to find. They identify patterns, assess the severity of damage after a disaster, pull out crucial insights. It's about speed and scale that humans just can't match manually.
So it's moving beyond just looking at pictures to really understanding what's in them.
Precisely. Companies like EOS Data Analytics, they're constantly refining their AML algorithms. They're pulling in data from drones, from IoT devices, integrating it all.
What's goal there?
Ultimately, to build sophisticated early warning systems for natural disasters. To try and predict the likelihood of an event, understand its potential impact on, say, agriculture, estimate the economic losses, moving from just reacting to disasters to proactively building resilience.
That makes sense. Now, I read about something called the GDLT project. That sounds like it takes data analysis to a whole other level, monitoring global society itself.
GLT is.
Yeah.
Yeah, it's pretty remarkable. It uses really sophisticated AI, natural language processing, deep learning to essentially read the world's news media. in over 100 languages.
100 languages. Wow.
Yeah, and it extracts information over 300 categories of physical activities, millions of themes, thousands of different emotions expressed in the text, and it updates every 15 minutes.
Every 15 minutes. How does it structure all that?
Well, it has different layers. The GDL event database takes unstructured text, like a news report saying country A criticized country B for troop movements,
Yeah.
and turns it into structured data, who did what to whom, where, when.
Okay.
Then there's the global knowledge graph that compiles all the entities, people, places, organizations, and the emotions linked to them, creating this huge dynamic network map of global society.
And it looks at images, too.
It does, the visual global knowledge graph. It processes millions of images daily using Google's Vision API. It annotates objects, activities, reads text in images, identifies locations, even analyzes facial expressions for emotions.
That's a staggering amount of information. And it's available.
Amazingly, yes. All this data is freely available for anyone to access and use for research. It's an incredible open resource.
This sounds like it ties directly into what people call open source intelligence, or OSINT, using publicly available data to find insights.
That's a core part of it, yeah. OSINT is all about extracting valuable intelligence from information that's already out there in the public domain.
And that's used in lots of different fields.
Oh, yeah. Hugely important for national security, law enforcement, business intelligence, cybersecurity, and definitely journalism.
What kind of tools do OSINT analysts use?
All sorts. Deep analysis of social media, web scraping tools to gather data from websites, geolocation techniques to pinpoint where photos or videos were taken, advanced image and video analysis, think facial recognition, object detection, even monitoring the dark web sometimes.
So it's like being a digital detective, piecing together clues from everywhere.
That's a good way to think about it. Meticulously gathering and analyzing all those publicly available puzzle pieces to build a comprehensive picture of what's happening.
This sounds like really specialized expert work, but there's also this trend of involving the public more directly, right? Through citizen science.
Yes, absolutely. Citizen science is basically getting everyday people, individuals who aren't professional scientists, actively involved in the scientific process.
How does that work? What do they do?
It can range quite a bit. Sometimes it's data collection, people making observations, taking measurements. Other times it might be helping analyze data or even helping design the research project itself.
But why is that useful, especially when we have these incredibly precise satellites and sensors? What can citizens offer?
That's a great question. Humans offer things sensors can't. We bring different perspectives. We can observe things at different times or in different places that a satellite might pass over. We can react flexibly, like if a flood destroys automated measuring stations, people can still report what they see. And sometimes human perception is just easier to interpret for certain things, like changes in outdoor lighting at night. Satellite data on light pollution might show one thing, but the actual human experience on the ground could be different. Citizen reports help calibrate that.
Are there good examples of this, say, from GFZ, the German Research Center?
Yeah, GFZ has some really cool projects. They have one called Loss of the Night app, where people literally help record light pollution by counting visible stars in their location. That provides valuable ground truth data.
So comparing what people see to what satellites see.
Exactly. Then there's Agrison's Demon 4.0, where they involve farmers directly. The farmers use their local knowledge to help map low-yield areas on their farms, making the satellite data much more practical and accurate for them.
And using social media.
Yep. They developed software called Post Distiller that uses photos people post on social media during floods to rapidly map how far the water has spread. It's leveraging what people are already sharing.
So it's tapping into collective observation power, especially for mapping.
Precisely. We saw the power of this with OpenStreetMap after the Haiti earthquake. They used free satellite imagery, and thousands of volunteers around the world helped map the affected areas, roads, damaged buildings.
Right.
Crucial for the recovery effort. And like we mentioned, Amnesty's Decode Darfur project was another massive example of this microtasking collaborative mapping. It really shows how countless small contributions from citizens can build up into a powerful global monitoring tool.
Okay, the benefits are clear disaster response, science, journalism, human rights, but this increasing power, this resolution, the sheer amount of data from these eyes in the sky, it inevitably brings up some really tough ethical questions.
Absolutely unavoidable.
So what does it all mean for things like personal privacy? or even national security, when a satellite can literally see into your backyard.
It forces us to grapple with that idea of a reasonable expectation of privacy, doesn't it? And the truth is, most people probably don't realize just how much information satellites can gather. That really blurs the lines.
Is there a legal standpoint on this? Like your backyard example.
Well, there's the famous case, Curtis Croft, arrested for growing marijuana. The evidence, Google Earth imagery of his backyard. The legal argument was basically that his backyard was publicly exposed to satellite view, so no warrant needed. No expectation of privacy from the sky, legally speaking, in that context.
That's unsettling.
It is. And the risks go beyond individuals. Remember that incident in 2018? A fitness tracking app released a heat map showing user workout routes.
Oh, I remember that. It showed military bases. Right?
Exactly. It inadvertently revealed the locations and patrol routes of personnel at secret military bases around the world, all built from perfectly legal, aggregated user data, a massive security breach from seemingly harmless info.
And you mentioned revictimization earlier, too.
Yeah, that's a huge concern in humanitarian contexts. If you release precise geographical coordinates alongside images of, say, camps for displaced people in a conflict zone, you could inadvertently put extremely vulnerable people at greater risk for the very groups they're fleeing.
So how is all this regulated? Is there an international law, or is it country by country?
It's complicated. The foundational treaty is the Outer Space Treaty of 1967. It basically establishes space as a global commons, meaning states can freely explore and use space. And crucially, it permits them to freely collect and distribute remote sensing data satellite imagery without needing consent from the country being observed. It's the open skies concept.
So anyone can image anywhere. No permission needed.
Pretty much. Which leads to this incredibly transparent global environment, but also means each country is responsible for regulating its own commercial satellite operators.
How does that work in the U.S., for instance?
In the U.S., companies need a license to operate a remote sensing satellite. But policy changes, like a directive in 2018, basically said companies can sell images of a certain quality if similar imagery is already available commercially on the international market.
Why is that significant?
Because other countries, say India or China, might have less strict regulations. So a foreign company could potentially collect and sell imagery over sensitive U.S. locations that a U.S. company might be restricted from distributing due to national security concerns. It creates tricky loopholes.
Are there any specific national restrictions, then, to counter the open skies idea?
Yes, some specific carve-outs exist. In the U.S., there's the Kyle-Bingaman Amendment. It specifically prohibits licenses for selling high-resolution satellite imagery of Israel. Images of active U.S. military operations are also generally restricted.
Interesting. And what about this technology gap you mentioned, states holding back tech?
Right, that's a deliberate strategy. The countries leading in satellite tech, often governments developing it for military or intelligence use, first tend to slow down the transfer, the spin-off, of the most advanced capabilities to the civilian or commercial sector.
How long a delay are we talking?
Often around 5 to 10 years. It's done to maintain a strategic military or intelligence advantage over potential adversaries. But the downside is, it can limit how effective humanitarian efforts can be, because they don't always get access to the absolute best, most timely data when they need it.
It sounds like the engineers actually building this stuff have a massive ethical weight on their shoulders.
They really do. Professional organizations like the AIAA, the American Institute of Aeronautics and Astronautics, have codes of ethics. A key principle is often something like holding paramount the safety, health, and welfare of the public.
So they need to think about the downstream consequences.
Absolutely. They have a responsibility to think about where the ethical lines are for collecting information about the public, and crucially, to maybe push back against developing technology that clearly crosses those lines. It's about innovating responsibly.
Okay, so the tech is amazing, but it's not perfect. There are still challenges and limitations, right? It's not a magic bullet for every problem.
Definitely not. Huge progress, yes, but still significant gaps. For many organizations, especially smaller NGOs or local governments, getting tailored solutions isn't easy or cheap. High-res, frequently updated imagery still costs real money.
And the images themselves only tell part of the story.
That's a critical point. Satellite images show what is there, but not necessarily why. They don't show causality on their own. You always need to corroborate with other evidence, ground reports, expert analysis, and there's always a risk of misinterpreting an image if you lack context.
Are there technical hurdles, too?
Sure. You still need specialized software to process and analyze a lot of this data effectively. You need trained analysts, people with geospatial expertise. And if you rely on external analysts, that can bring up issues around confidentiality or the ability to get independent peer review of the findings.
We also talked about this idea of living in a permanent crisis. How does satellite data interact with that?
Well, in an environment where information or misinformation spreads so fast, satellite data can be incredibly powerful, but it can also be misused, right?
Hmm.
Cherry-picked images, data taken out of context to mislead people or just amplify existing biases.
And the sheer volume of data itself is a challenge.
It is. Processing these massive data sets efficiently is still hard work. And the ethical concerns around privacy just keep growing as the data gets better and more pervasive. Especially sensitive data collected by, say, humanitarian groups, ensuring that doesn't fall into the wrong hands is paramount. It's a constant tightrope walk.
Looking ahead then, this trend towards more access, this democratization of data, is that likely to continue?
All the signs point that way, yeah. You've got huge investment, both government and private, driving down the costs of building and launching satellites. Especially these smaller ones, the mini and microsatellites, CubeSats. Yeah, they're tiny, relatively cheap satellites you can launch in large numbers, creating constellations. These constellations can provide much more frequent revisits over areas, enabling near-constant monitoring, often at lower cost.
So more data, more often, for more people.
That's the promise. It opens up huge opportunities, especially for academic researchers studying global environmental change or for smaller organizations monitoring specific issues.
What are the technologists buzzing about? What's the next big thing in satellite capabilities?
Two things consistently come up. Further advances in SAR, that radar tech we talked about.
Seeing through clouds, yeah.
Right. Getting even better resolution and capabilities there. And the other big one is satellite IoT, the Internet of Things.
Connecting devices via satellite.
Exactly. Enabling tracking and communication with sensors and devices literally anywhere on Earth, no matter how remote. Think tracking global supply chains, monitoring remote environmental sensors, agriculture tech. The potential is enormous for identifying and tracking traceable objects globally.
It really sounds like making the most of all this requires, well, everyone working together.
It's absolutely key. The full potential here. It really hinges on collaboration between the tech companies building the satellites and AI, local governments needing the insights, research institutions pushing the boundaries, universities training the next generation of analysts.
To build those innovative projects, those early warning systems.
Exactly. It has to be a collective effort if we really want to build more resilient communities and make smarter decisions about our planet.
And for some companies in this space, like EOS Data Analytics, there's a very explicit link to global goals.
Yeah, absolutely. Their stated vision is pretty clear, making space technology a key driver for global sustainability. They actually align their work with 10 of the 17 UN Sustainable Development Goals.
So using this view from space to help achieve things like food security, clean water, climate action.
Precisely. Aiming to contribute directly to more resilient communities and, ultimately, a more sustainable future for everyone, it's harnessing that powerful perspective for positive global impact.
Okay, so we've journeyed from the basics of satellite tech to AI analysis, humanitarian aid, journalism, ethics. It's a vast landscape. We've seen how these eyes in the sky, supercharged by AI, give us this unprecedented view of our world. From like the tiniest details of crop health right up to the massive scale of global conflicts and changes. So here's a final thought to leave you with. Given this relentless improvement in resolution, the sheer reach of satellite data, and the ever smarter AI processing it, how might our whole understanding of what's public versus what's private space fundamentally change in the years to come? And what new responsibilities does that put on all of us as people who both create and consume this data?